Snoqualmie Pass is closed in both directions and will remain closed until at least Saturday due to dangerous driving conditions. So big news.
What if the ground beneath your feet isn't as solid as you thought? What if scientists have discovered something so vast, so unpredictable, and so dangerous right beneath Washington State that they're now sounding the alarm? In April 2025, a team of geophysicists made a discovery that could change everything we thought we knew about the Pacific Northwest. What they found wasn't just another volcano. It was something deeper, larger, more alive. Let's explore the discovery beneath Washington that has scientists deeply concerned, and why time might be running out. A mystery beneath the mountains. Washington State, draped in coniferous forests and crowned by the glaciated summits of the Cascade Mountains, is known for its natural beauty. But few realize the geological powder keg hidden beneath its landscape. Stretching from Mount Baker in the north to Mount Adams in the south, the Cascade Arc defines Washington's volcanic backbone. Beneath these peaks lies a complex and poorly understood network of magma bodies, subduction zones, and fault lines. In early 2025, deep beneath this iconic terrain, the Earth sent out a new kind of signal. It didn't begin with a bang. It began with a whisper. A low, haunting vibration felt only by the most sensitive instruments buried in the mountain range. These weren't the sharp jolts of tectonic quakes, nor were they the icy creaks of glacial shearing. These tremors pulsed. They hummed. They moved. Originating from depths of 30 to 45 kilometers below the surface, they traveled deliberately, shifting from the vicinity of Mount St. Helens, past Rainier, and arcing toward the Seattle Fault Zone. Initially, scientists theorized groundwater movement or deep tectonic creep, but these pulses were too patterned, too synchronized. They formed a migrating wave, what some experts now compare to a pressure front within a massive magmatic system. Soon after, other signs emerged. Magnetotelluric arrays detected a sharp rise in subsurface conductivity, an indication of superheated, partially molten rock. GPS sensors installed across the Cascades began picking up micro-uplift, suggesting the land itself was being subtly pushed upward. In several boreholes, temperature anomalies were recorded, up to 15 degrees Celsius hotter than expected, with localized spikes in radon and mantle-derived helium-3 gas. This wasn't a typical tectonic event. It was deeper, more powerful, and far more mysterious. Geologists now believe they've discovered the edges of a vast, awakening magma corridor, one that stretches beneath Washington's volcanic spine and pushes disturbingly close to densely populated urban zones. What lies beneath the peaks and valleys of Washington may not just be ancient rock and sleeping faults. It could be a molten leviathan stirring beneath our feet. And what it's whispering now could one day erupt into a roar. The three-dimensional image that changed everything. It was supposed to be a routine imaging operation, another layer added to the geological map of the Pacific Northwest. But what researchers from the USGS and Caltech uncovered in early 2025 was anything but routine. Using advanced seismic tomography, essentially a CAT scan of the Earth's interior, scientists constructed a high-resolution, three-dimensional model of the crust beneath western Washington. Feeding data from over 400 seismic stations and integrating INSAR satellite deformation readings, the team processed months of subsurface echoes to reveal something unprecedented. A massive, semi-molten chamber, vast beyond anything previously detected. Stretching from the base of Mount St. Helens in the south, through the colossal plumbing beneath Mount Rainier, and extending deep into the crust under eastern Seattle. This wasn't a series of disconnected magma pockets. This was a corridor, a single, unbroken reservoir of partially molten rock, hot, pressurized, and rising. The thermal gradients shocked even the most seasoned geophysicists. Some sectors showed crustal temperature increases of up to 40 degrees Celsius in less than 6 months. Melt percentages reached over 20% in certain areas, placing the material dangerously close to eruptible thresholds. The upper dome of the chamber is now just 10 kilometers below the surface in some zones, a depth geologically considered shallow. But it wasn't just the size, it was what it meant. Ground uplift, previously dismissed as seasonal variation, now aligned perfectly with the bulging edges of this magma corridor. Gas emissions from surface vents, particularly CO2, SO2, and helium-3, were now understood as warnings, not anomalies. And then there were the fractures. The model revealed spiderweb-like weaknesses in the surrounding rock, zones where seismic pressure has already caused microcracks to open, forming escape routes for gas and potentially for magma itself. Was this corridor created recently, or has it always existed, dormant and undetected under our feet? If awakened, could it erupt in one place, or in many, almost simultaneously? One geologist who reviewed the imaging report whispered the question everyone feared. What if this isn't a volcano? What if it's a system? And what if the system has started to stir? Signs of pressure buildup. The first true warning didn't come from beneath the volcano. It came from the sky. In March 2025, satellites orbiting 500 miles above the Pacific Northwest detected something alarming. Surface uplift around Mount Rainier was accelerating. At first, scientists believed it might be seasonal, a shift from snowmelt or groundwater expansion. But then came the gas, carbon dioxide, sulfur dioxide, hydrogen sulfide, the unmistakable chemical fingerprints of magma degassing. Near the summit of Mount Rainier, sensors began reporting anomalously high concentrations of these volcanic gases, not once, not occasionally, but daily. Each spike a whisper from the Earth's hidden engine, signaling that magma was moving. And not just under Rainier. Stations installed along the Nisqually and South Whidbey Island fault systems began to pick up something else: low-frequency harmonic tremors. These aren't random shakes. They're the eerie, drum-like vibrations associated with rising magma pushing through rock, warping stone, and seeking release. As the tremors intensified, so did the heat. Borehole arrays near the Carbon River showed ambient temperature increases of nearly 8 degrees Celsius over historical baselines. Groundwater samples collected across the western slopes tested positive for elevated radon gas, a known precursor to seismic activity linked to pressure changes in the crust. Soon, even more data began converging. Time-lapse satellite imagery showed that ground uplift was not localized. It extended in a radial pattern, forming a shallow dome-like swell around Rainier's base. The scale of deformation suggested the presence of a growing, pressurized reservoir, not a temporary fluctuation. Isotope analysis of the gases revealed further insights. The helium ratios contained an unusually high 3-to-4 helium signature, indicating the gases were sourced from deep mantle plumes rather than shallow crustal rock. That's the same fingerprint geologists found before the 1991 Mount Pinatubo eruption. Using numerical modeling, researchers calculated that the stress accumulation beneath Rainier had reached a critical point. The cap rock, a dense crustal layer above the magma body, was showing signs of fracturing under thermal stress and hydraulic pressure. If the pressure breaches the cap, a sudden explosive eruption could follow, especially if hydrothermal systems above it flashed to steam. Geologists began to see the pattern: thermal updrafts, accelerated degassing, harmonic tremor, surface deformation, high mantle gas signatures, cap rock destabilization. All of it pointing to one terrifying conclusion. The magma beneath Washington wasn't just shifting, it was rising, expanding, preparing. One volcanologist, reviewing a composite graph of gas emissions and tremor intervals, said it plainly. It's like listening to a sleeping giant begin to hyperventilate. Could it erupt tomorrow? Maybe not. But make no mistake, this system is waking up, and we're already hearing its first breath. The connection to Seattle. When most people think of volcanic danger, they picture remote, smoking peaks far from cities, majestic, distant, and silent. But in 2025, scientists revealed something that turned that assumption upside down. The magma system beneath Washington may be reaching into the heart of the state's most populated urban corridor. Recent seismic tomography, compiled from data by the Pacific Northwest Seismic Network, PNSN, and U.S. Geological Survey, has mapped a westward extension of the partially molten corridor under Mount Rainier. The corridor appears to stretch beneath the Kent Valley, eastern Tacoma, and as far north as Issaquah and Bellevue. In some regions, particularly east of Tacoma, the top of the magmatic body lies a mere 8 to 10 kilometers below the surface, dangerously shallow by geological standards. That's comparable to pre-eruption magma depths at Mount Pinatubo and Soufriere Hills. This proximity is especially alarming given the hydrogeological profile of the Puget Sound region. Deep aquifers crisscross the corridor, many of which supply drinking water and feed major rivers like the Green and White Rivers. According to modeling by the University of Washington's Department of Earth and Space Sciences, if magma breaches into one of these aquifers, it could cause a phreatomagmatic eruption, an explosive interaction between magma and groundwater. These steam-driven blasts occur with minimal warning. They do not need a massive magma volume to devastate local infrastructure. Instead, rapid flashing of groundwater into high-pressure steam can cause rock fragmentation, ground failure, and even crater-forming eruptions. Traditional volcanic monitoring tools, like surface gas sensors and shallow seismic arrays, are often ineffective in blind zones like these. Urban development muffles subtle signals. Deep gas channels are blocked by impermeable rock, and electromagnetic interference from city infrastructure can disrupt magnetotelluric imaging. Still, clues are emerging. INSAR satellite data has revealed slow ground uplift east of Tacoma, less than 5 millimeters per year, but regionally consistent. Drone-mounted infrared sensors, flown by USGS teams, detected an anomalous warm zone south of Lake Tapps. And elevated SO2 emissions were recently recorded near Mud Mountain Dam, where no volcanic activity was previously believed to exist. So what would an eruption look like beneath this corridor? In one worst-case scenario, modeled by the Cascadia Geohazard Initiative, a rapid phreatic or phreatomagmatic eruption near Auburn triggers slope collapse into the Green River. Lahars flood 25 miles downstream, reaching Kent and parts of Renton in under 90 minutes. Simultaneously, ashfall from a hydrothermal explosion shuts down SeaTac Airport and blankets Interstate 5. Public safety officials estimate over 120,000 people could be affected within hours. And the most chilling part? This scenario doesn't require a super eruption. It only requires one point of failure in an increasingly unstable system. Seattle, Bellevue, Tacoma, these cities may not sit beside the volcano. But according to the latest maps, they now sit atop it. And the question scientists are quietly asking is no longer if, but when. Is this part of something bigger? What if Washington's rising magma corridor isn't the exception, but just the beginning of something far more extensive and far more dangerous? New interdisciplinary studies released in April 2025 have revealed compelling geophysical links between Washington's deep magmatic structure and neighboring volcanic provinces. Cross-border tomography data shows a continuum of elevated heat flow and low seismic velocity zones extending southward into Oregon's Three Sisters complex and California's Mount Shasta system. In other words, what lies beneath Mount Rainier may be connected, directly or indirectly, to a broader corridor of molten material spanning 3 states. Researchers at the University of Oregon have identified synchronous surface deformation events in both Washington and Oregon. During one 3-week period in late 2024, satellite data showed a subtle but measurable uplift occurring simultaneously near Rainier, Crater Lake, and the Three Sisters. A coincidence? Perhaps. But the chemical signatures tell another story. Gas samples from surface vents in both Washington and Oregon now show similar helium-3 to helium-4 isotope ratios, indicative of deep mantle-derived gases. These rare ratios are normally unique to individual systems. Finding them duplicated across multiple sites suggests a shared source, or, at the very least, a connected reservoir. And it doesn't stop at Oregon. The same anomalies, elevated crustal heat, microseismic swarms, and increased SO2 emissions, have been observed near Mount Shasta in Northern California. While no official statement has confirmed a direct underground connection, the patterns are troubling. Could the Pacific Northwest be sitting atop a mega network of volcanic activity? A linear threat buried beneath ancient forests, fault lines, and modern cities? Some geologists now fear this is the early ignition phase, a slow cascade of pressure buildups that, once unleashed, could trigger sequential eruptions or widespread magmatic surges. The idea isn't science fiction anymore. It's becoming a hypothesis that even the most cautious experts are no longer ignoring. The risk to millions. More than 7 million people live in the potential impact zone of Washington's growing magma corridor, and that number could be conservative. From Olympia to Seattle, from Tacoma to Everett, entire metropolitan areas rest atop ground that's showing signs of unrest. But here's the catch. Most emergency preparedness plans have been built around individual eruption sites, Mount Rainier, Mount St. Helens, or Glacier Peak, not a multi-point, system-wide scenario. And yet, that's exactly what geologists are now warning about. Critical infrastructure, hospitals, airports, energy grids, and communication lines all sit within the projected ashfall and lahar zones if even a moderate eruption were to occur near Mount Rainier or its satellite faults. Power plants could be knocked offline. Ashfall could clog water treatment systems and overwhelm emergency services. Highways like I-5 and I-90 could be buried beneath volcanic debris or swept away by lahars, massive walls of superheated mud and rock moving faster than a car on the freeway. In some simulations, emergency response times drop to near zero for cities like Puyallup or Auburn. But the most terrifying scenario is not one eruption, it's multiple. If the corridor destabilizes in multiple zones at once, driven by rising pressure and interlinked faults, the Pacific Northwest could face a cascade of eruptions, each triggering or amplifying the next. Skies would darken for days, flights would be grounded, rainwater would become acidic, and as the ash spreads, so does the chaos, interrupting food supply chains, overwhelming hospitals, and shutting down the ports of Seattle and Tacoma, two of the busiest trade hubs on the West Coast. This isn't just a geological event. It's a civil emergency waiting to happen. And right now, no one can say how much time we have left. What scientists are doing now? Across Washington state, scientific teams are no longer studying a distant geological curiosity. They're monitoring a rising threat. The USGS, in collaboration with several major universities and international seismic networks, has declared a heightened observational phase. In the past few weeks alone, they've deployed over 80 new seismometers across the Cascade Corridor, some buried deep in hardened volcanic rock, others mounted on fault-fractured ridgelines. These instruments are sensitive enough to detect quakes smaller than magnitude 0.1, the faintest footfalls of rising magma. Meanwhile, drones equipped with hyperspectral cameras sweep the skies above Rainier, St. Helens, and even as far north as Glacier Peak. They're mapping thermal anomalies with pinpoint precision, revealing strange heat signatures in zones previously thought geologically inactive. Orbiting satellites from NASA's Earth Observatory and ESA's Sentinel program now focus twice daily on the Pacific Northwest, measuring deformation in micrometers with radar interferometry. When paired with the swelling patterns of GPS data, they're helping build a real-time model of magma movement beneath the surface. Below ground, magnetotelluric stations are humming, listening for electromagnetic shifts that signal the movement of fluids through conductive rock. Several of these stations have already reported low-resistance zones forming unexpectedly beneath known faults. And the gas? It's rising. Radon, sulfur, carbon dioxide, and traces of helium-3 continue to seep from monitoring wells and summit vents. Their ratios, combined with temperature shifts and isotopic profiles, are being fed into machine learning models trained to predict magmatic ascent. This isn't just research anymore. It's reconnaissance. Because uplift, tremor, degassing, and thermal anomalies are no longer theoretical markers. They're converging. There may be no eruption warning yet, but the system is escalating. And as one geologist from the Cascadia Research Collective stated, we're not just watching volcanoes anymore. We're watching a system preparing to act. The Earth doesn't always scream before it moves. Sometimes it murmurs, deep and low. Beneath Washington, something is murmuring now, and scientists are listening closely because they know what might come next. Like this video if you want real-time updates on this developing story. Subscribe to stay informed about Earth's hidden threats. Let us know in the comments. Is Washington the next eruption zone or the first in a chain reaction? Thanks for watching. And remember, beneath our feet, the Earth is always moving.